Okay, so this is the next method in solving quadratics, which is completing the square. And in order to complete the square, we need to make sure that our trinomial is a perfect square trinomial. And in a perfect square trinomial, the last number would be half of the middle term squared. I had a marker. So you're going to take the middle term, you're going to divide it by 2, and then you're going to square it. That'll give you your C. So here we have 18 divided by 2, which is 9, and 9 squared, which is 81. That'll make this a perfect square trinomial. Take a second and try to find the next 3. Okay, so go ahead and check your answers. You're going to notice that the next 2 are pretty simple and straightforward. You just divide by 2 and square. Don't worry about the negative, because when you square it, that would become positive anyway. If you look at the last one, it becomes a fraction, 5 over 2. Do not change that to a decimal. Leave it as 5 over 2 and square each number so you end up with 25 over 4. That's going to make it easier when you're actually completing the square. So if we look at this problem, x squared plus 6x minus 216, this is not easy to factor because we don't off the top of our head know the factors of 216, and it might not even work. So what we do is we complete the square. And in order to complete the square, the first thing you need to do is create a perfect square trinomial. So we need to get rid of this c because we need to put in our own c. So I'm going to move that over to the other side. I'm going to add 216 to this side. That's going to leave me with x squared plus 6x equals 216. Now I want to put in my own c, so I'm going to make a space right after the 6x for my new c. But whatever I do to one side, I have to do to both sides. So I'm also going to put a space next to the 216 that I moved over. Then we're going to find our c, which if you remember what we just did, you take half of the middle term and square it. So that'll end up being 9. So I now have x squared plus 6x plus 9 equals 225 when I add those together. And I need to factor this part over here. So if I factor this, my signs are going to be the same. They're both going to be plus signs. Factors of 9 that add up to 6 are 3 and 3. So I end up with x plus 3 times x plus 3 equals 225. And as we know from the last chapter, when you have 2 of the same parentheses, you can rewrite it squared. So you have x plus 3 squared. Let me erase this so you can see. X plus 3 squared equals 225. Now in order to solve this, I need to take the square root to get rid of the square. So that's going to cancel out the square. And that's going to leave me with just x plus 3 equals plus or minus 15, because any root comes out as a plus and a minus. And that I'm going to write as, I'm going to move over the 3 to get x by itself. And I'm going to solve this by splitting it up into 2 equations. So one of them is going to be here, negative 3 plus 15, and the other one's going to be here, negative 3 minus 15. And that'll give me my 2 answers to that quadratic. Since these are whole numbers, I know it would have factored, and these would have been my numbers in the parentheses. But sometimes you're not going to get actual numbers, you're going to get roots. Okay, let's look at this example. The 144 is already moved over, so all I have to do is go ahead and make my space for my new c. Now, if I take half of the middle term and I square it, I'm going to end up with a fraction. And that's okay. I can have a fraction. I'm going to put that into my blanks. And then I'm going to factor. And since I know this is going to be the square root of this number, I'm just going to use what it was before I squared it, which is 7 over 2. Because that's what makes it a perfect square trinomial. Here, I'm not going to be able to add these together until I get a common denominator. So I'm going to change this to be 144 over 1. I'm going to change it to have a denominator of 4. And if I multiply that by 4, I get 576. So now I have 576 over 4 plus 49 over 4. Okay, this I'm going to rewrite as a square. And when I add these two together, I'm going to get 625 over 4. Take the square root to get rid of the square. So I get g plus 7 over 2 equals plus or minus, and these are both perfect squares, so 25 over 2. Move over the 7 over 2. So I get g equals negative 7 over 2 plus or minus 25 over 2, and I can split that up into two equations. Okay, so now we're going to split into two. Negative 7 over 2 plus 25 over 2, and negative 7 over 2 minus 25 over 2. Negative 7 plus 25 is going to give me 18 over 2, which is 9. And negative 7 minus 25 is going to give me negative 32 over 2, which is negative 16. So those are my two answers, 9 and negative 16. So I want you to go ahead and try one. Why don't you go ahead and try this one on your own. If you need to, you can go back and refer to the other ones. Take a second, pause, because when you come back on, the answer is going to be there. Okay, notice how in your answer you have a square root, so you're not going to have a perfect whole number, and you can leave it like that with the root. Go ahead and try this problem. Make sure that you divide everything by 4 first, because your a squared has to be by itself. You cannot have anything in front of it in order to complete the square.